And hello and welcome back to our OneClass live stream. Again, my name is Joey. I'm going to be your math teacher for this session. If you're new to OneClass or you're just checking us out for the first time, thank you so much for watching. A little bit about OneClass before we start today's session. OneClass is kind of like an online resource program for students such as yourselves that you might be tuning in from home or from your devices anywhere in the world. What we're doing and what we're providing here at OneClass is we're providing online resources and live streams and videos for students at home in subjects such as in secondary level math and secondary level chemistry as well. So what we're doing here in the session, or what I'll be doing here in the session, is that I'm going to kind of go over some frequently asked questions in these subjects. And what I'm going to do is I'm going to verify the solutions with you. So I'll teach you how to do the questions in itself, and I'll analyze the solutions while we do that. And then I'll kind of go over the concept of what we are doing behind the question as well. So without further ado, let's get started on our video for today and our sessions for today. So these 10 questions are going to be these 10 questions were kind of used in or kind of adhere to the grade 9 algebra, grade 9 geometry, and algebra 1 type of questions. So it's kind of any questions that you frequently see in grade 8 or grade 9 math here. All right, let's get started then. Okay, so we have here, it says, our first question today says, write 4.8 as a fraction. So let me just write that down for us here. I have to refresh the page. Here we go. I'll wait for my pen to kind of activate here. There we go. Okay, so it says here. Oh no, where'd it go? There we go. This is write 4.8 as a fraction. So this is kind of our first first question here. It says write 4.8 as a fraction. So we're converting from basically this here is a decimal, because as you can see we have a decimal point on here, and we are going to convert basically from a decimal to fraction to a fraction. So basically we're going to convert a decimal to a fraction. How do we do that first? So if I'm given 4.8 as my decimal, I have here 4.8 as my decimal, I could rewrite this as a mixed fraction first, right? And how I would do that is I would, I have basically the whole part of the decimal. So this left part here is the whole part. So I can say this will be a whole number. And then anything after the decimal here is the decimal part, or the fraction part. So it's the decimal part here. So if I were to write this in a mixed fraction, if I want to convert this into something called a mixed fraction here, I would have two parts. I would have the whole part of the fraction, and I would have the fraction part, right? So the whole part is obviously this number 4, right? Whatever is to the left of the decimal place. So I would say here, I would write 4 here. And then the decimal point, the decimal part is going to become our new fraction part, right? It's going to become our new fraction part. So if I have 0.8 in this case here, I know a decimal here in the first digit here is the 10th or the tens digit, right? Or the tens place, right? So if I know it's a tens place, then 0.8 would simply just be 8 over 10, right? 8 over 10 would be the equivalent fraction for 0.8 here. So I'm going to write here 4 and 8 over 10. And this here is our mixed fraction for our for 4.8. And what we can do is we can actually convert now between this mixed fraction here, we can convert it to a improper fraction. So in order for us to do that, so if I want to convert into something called an improper fraction, so what I would have to do in terms of improper fraction is I would basically take my mixed fraction here. I would take my whole part and I would multiply it by the denominator and add it to the numerator. So what I'm going to do here is I'm going to have my 4 here. I'm going to multiply it by 10. Sorry about that. So I'm going to multiply it by 10, and then I'm going to add it by 8 here. I think I'm good. Okay, sorry about that. So again, I have my whole number part here, and I'm going to multiply it by the denominator. So it's going to be 4 times 10 here, and then I'm going to add it, take that number, and add it to the numerator. So I have 4 times 10 plus 8, right? So 4 times 10, and I'm going to add it to the numerator here. So if I have 4 times 10 here, I have 40, and 40 plus 8 is 48, right? So this would be 48 here in the numerator. In terms of our new numerator. And then it's obviously, we keep the same denominator, so it'd be over 10 still here. And what we can do is we can actually reduce this. We can reduce this fraction, right? We want it to always be the lowest terms and whatnot. So if I were to reduce 48 over 10 here, I would have to I would have to basically pick the greatest common factor between the numerator and the denominator. So in this case, I would probably pick 2 first, because I have both my numbers are even, right? So if I divide by 2 in the numerator, divide by 2 in the denominator, here, this is going to equal 40 divided by 2 here is 24. And then finally 10 divided by 2 here is 8, right? So in total, my final answer will be this number here. 24 over 5 here is 4.5 as a fraction. So this question was good here. They divided it. They figured this out by using kind of the same method as we did, but they didn't go through the mixed fractions into the improper fraction. They just left it at 48 over 10, and they didn't reduce it by the in lowest terms here. So I'm going to say here this is the correct solution in analysis. However, forgot to reduce to lowest terms. I'm going to say here 48 over 10 equals 24 over 5. So the solution here is correct. It's not fully correct because they didn't reduce it to lowest terms, but I think for the purposes of this question, I think it was okay for this question here. So the solution here is correct. All right, so kind of the same, going off that concept, it's kind of the same thing here, 2.8 as a fraction, right? So go slightly faster for this question here, but what we're doing again, we're converting fractions into, we're going from decimals to fraction, right? So number 2, I have 2.8 as a fraction. So maybe take a minute to think about this. I'm gonna see if I can get some more light in here, just to help with the camera. But it says here 2.8 as a fraction. Maybe take a moment to think about this question here. So what we're having here is we have 2.8 here as a fraction. So it's exactly the same thing as what we're going to do before, right? So again, we're converting from a decimal to a fraction, right? So exactly the same question as what we're going to do for number 2 here. So again, if we recall, what we're going to do is we're going to write this as in terms of, we have 2 parts to a decimal here. We have the whole part and the decimal part. We convert it to what is a mixed fraction first, with the whole part into the fraction part, and then we convert to improper fractions and reduce if possible, right? So that's what we're going to do exactly for the same question here. So I have 2.8 here. So 2.8 means that my mixed fraction, so this is my decimal here, would be, my mixed fraction would equal, basically my whole part is, and I have 2 as my whole part, and then 2 here is my whole part, obviously, and then 0.8 here will be my fraction, right? And I know, again, it's in the 10th digit, so it's going to be 8 over 10 here. So again, I have my mixed fraction here. And then what I'm going to do to this is I'm going to, again, convert this into an improper fraction and reduce to lowest terms, right? So, again, I have 2. What I'm going to do is I'm multiplying by the denominator, and then I'm going to add it to the numerator, right? So I have 2 multiplied by 10 here and add to the numerator, right? So 2 times 10 is 20, plus 8 here would be 28, right? I have 28 over 10 here is my improper fraction. And then what I can do to this is I can reduce to lowest terms, right? As you can see here, 28 and 10, I have 2 even numbers, so I'm going to take it maybe 2 out of, divide both sides, or do both parts by 2. And then I'm going to get 28 divided by 2 here is 14. And finally, 10 divided by 2 is 5. So this here is our answer here, 14 over 5. And as you can see, this here is the correct answer as well. 14 over 5 is the correct answer. In this case, the student decided to reduce to lowest terms, which is perfect. And that's what we did over here as well. So they got 28 over 10 here. And then they got 14 over 5. And this here is the correct solution, right? It's correct solution and analysis here. Awesome. So that's number 2 here. Let's go to number 3. So number 3 is asking us, what is the square root of 21? So what is the square root of 21? And what we can do is we can actually we know the square root kind of looks like this. This kind of looks like this sign over here, and we know it's 21 inside the square root, right? So it's asking us, what is the square root of 21? And what we could do to this question is we could try to simplify it in terms of a perfect square. So we could see if we can find whether or not this is a perfect square. Or we can basically convert it to what I call a simplified radical form. So simplified radical form to see if we can get an integer and also a radical as well to simplify this. So if we look at 21 here, I know it's not an even number, but I know this here is divisible by 3. So if I divide by 21 by 3 here, I'm going to get root 3 times 21 divided by 3 here is 7, right? Divided by 7 here. So I have root 3 times 7 here. Both of these guys, both of these guys are prime numbers, right? So that means that the most simplified form of root 21 here is simply just 21. So in this case, this isn't really there's no really prime factors here. So we basically just have to solve what root 21 here is. What we can use is, again, we can use the method ask solution for us to figure out kind of up to 2 decimal points as to how to figure figure this out in terms of decimals here. So maybe I'll show you that. I don't know if they show you here. Yeah, they didn't really show you here, but just a little recap. So if I have 21 here, I'm going to find what 2 numbers multiplied by each other would be closest to 21. In this case, it would be 4, right? 4 times 4 is closest to 16 here. 5 times 5 is 25, but it goes over than 21. So we're going to put 4 and 4 here, right? So 4 times 4 here is 16. And I'm going to have 5 here. And then I'm going to simply add 2 zeros. I'm going to add 2 zeros here. And then I'm going to multiply our quotient here, or our quotient here by 8, right? Or by 2 to get 8 for our second column here. And then I'm gonna start having decimals here, like so. So now it's asking us, okay, I have 48 and then I have 500 here. So what I can do is I can do something. I can find another place for a decimal here, right? So if I were to add let's say a 5, 4.58. If I were to add like I'm thinking of a number that goes into 500 from 48 here. I believe this would be kind of like it would be kind of using something that's greater than 10 here for this 500 here. But let me see if I can approximate that for you in terms of the method as solution here. We already know it's actually not in it's not in the simple it's already in simplified form here. So we really can't actually look into this and try to figure out whether or not we can actually grab some prime factors in order for us to kind of solve something like so. So give me a second here. So let me redo this question. So I have 4 here, and I have 500. Right? So I'm gonna multiply this by 2. So I'm gonna get 8 here as my factor here, and then I'm thinking of a number that goes into I'm thinking of a number squared here that can go into 500. So let's see. If I have 80, let me try 84. 84 times 4 would give me 336. What about 85 times 5? Give me 425, and 86 times 6 would give me 516. So I would have to put 5 here as my next number. And this number would be 5 here. And then 85 times 5 would be 425. Subtract those two numbers, I would get 75 here. And then I can add 2 zeros. And then again, I have now this here is a 5. So I'm going to have 85 plus 5 would make up my new guy here, which is 90. And I'm thinking of a number in basically this digit here and this digit here to go into 7,500. So let me try 97 times 7 would give me 6,349. And then 908 times 8 would give me 7,264, which I think would be the closest here. So I'm going to put in 8 here, 8 here. This would be 7,264. Subtract those two numbers, I get 296, I believe. And this one here, again, I only really care about 2 decimal places, but this here is our answer for square root of 21, right? 4.58 here is approximately 4.58 here. And we just use the method as solution to prove that this here equals 4.58. So I'm going to say the solution here is correct because they cannot simplify the square root of 21. Can also use method as long division method to solve for to approximate the square root of 21. Okay. Number 3, the next question here is number 4. It's saying here, what is the square root of 64? So give me a second here. So see here, what is the square root? Square root of 64. And again, what we can do is when we talk about this, talking the concept of square root, it's this guy here. 64 is going to be inside the bracket here. So it's asking us what is the square root of 64. So you can either do this in two ways. If you kind of like inspect it, you can kind of solve this question here, or you can use again prime factorization to solve this question here, right? So if I were to use kind of inspection here, I know 64 here. If I think back to my perfect squares here, you can think back to 2 times 2 is 4. You can think of 3 times 3 equals 9, so on and so forth. And the moment we get to like 8 times 8 here, this will equal 64, right? So if I know 8 times 8 equals 64, then I know, therefore, 8 squared has to be 64, right? So therefore, the square root of 64 here is simply 8. So this here is one way of solving it. You can solve it by kind of logic here, knowing that this here is a perfect square. If you didn't know it was a perfect square, what we can do is we can actually take out the prime factors of 64 to solve this. So in order for us to do that, we look at 64 here. We think about numbers that can be divisible by 64. So in this case, I'm going to go with 2 first, right? Because I know it's an even number. So root 64 here, I'm going to take out a root 2 here. And then 64 divided by 2 here would be 32, right? So it would be 32 here. So I basically took out the root 2 from 64. I can do the exact same thing with this this root 32, right? I can take out another root 2 here. Take out another root 2 here. Then I have 32 divided by 2 here. This will equal 16. And then finally, we know that, and if you didn't know by now, root 16 here equals 4. But if you didn't know that, we can basically, we can do this basically 2 more times to figure this out here. Root 16, I can take another 2 here. 16 divided by 2 here is 8. And then finally, I have root 2 times root 2 times, I can finally take out the last root 2 here, and I would get root 4, right? And I know that root 4 here equals 2 times simply just 2. I know that these two multiplied by each other is going to equal 2, and these two are going to multiply by 2. So I have 2 times 2 times 2, which is simply just 4 times 2, which here equals 8. So this here is my solution if you didn't know what the square root is, but I'm pretty sure you know that the square root of 64 here equals 8. So this is a perfect square question here. So solution is correct. Good analysis here. That's number 4. We look at number 5 here. It's asking us, speakers are listed by manufacturer of 720%, less trade discounts of 7% and 6%. What further rate of discount should be given to bring the net price to $587 here? So what question is this? I think it's question 5, I believe. Yeah, question 5 here. It's asking, so we have speakers. They were basically listed for a price of $720. And it says less trade discount of 7% and 6%. So it was already discounted from a earlier price. So it was discounted first by 7% and then after by 6%. And then we would get this price of $720 here. So it says which further rate of discount should be given to bring the net price. So this is the net price here. This here is also known as a net price. So net price to, I want basically another rate of discount to bring it down to $587. I want this here is my magic number. This here is the what the goal is, and then we would have to calculate the rate of discount here, and this would be in percentage, right? And we don't know this. We say it's X here. So this here would be, I'll call this not the net price, but the final price here. Final price. Okay, so in order for us to do that, what we can do is, again, we have the final price, and then we have the initial price as well, right? So what we can do is we can simply just divide. We can divide both these numbers here to figure out the percentage of how much the final price is of the initial price, right? So if I were to do that, I'll do some blue. I'm going to take basically the final price here. I'm going to divide it by the net price. I'm going to multiply it by 100% here. And this would give me how much does the final price, what percentage does it make up of the net price here. So I have final price here is, so I'm going to say it's 587 over net price here is 720 times 100% here. So 587 here. And then if I divide both of these numbers here, I'm going to get 587 divided by 720. This will give me decimal number of, this is here, 0.8152. I'm going to multiply that by 100%. This will give me about 81.52%. So this here is the percentage between the final price of the speakers and the net price of the speakers, right? So it makes up 81.52%, right, of the net price here. So if I want to find the rate of discount, so the rate of discount is simply just the percentage that is not included in this 81.52. So I can say rate of discount equals here 100% minus 81.52% here. And this will equal basically how much discount I'm getting, or the rate of discount, how much I'm taking off the net price here. So 100 minus 81.52 would give me a percentage of, this here is 18.48%. So I get a discount of 18.48% for me to solve to get $587 as my final price here. So 18.48% here is my final answer. And as you can see here, they wrote 17.72%, and this here is actually the incorrect answer, because what they did was they actually flipped these two numbers here. So it says the net price was 587, but they put 578 into their math here, though, so their answer is slightly off. So I'm going to say here solution is incorrect. Net price or discounted price is $587, not 578 like shown in your work. The discount is 18.48% to bring down the price to 587. So say the solution here is incorrect. Okay, number 5. Number 6 again, how many quarts are in a gallon? I think I've already done this question like a bunch of times. I feel like we're getting a repeat of these questions now. How many quarts in a gallon? And this here again is the empirical system here. So we're looking at, and we're measuring volume, right? So in this case, if I'm looking at my imperial system, basically, I'm going to look at, I have some conversions I can use, right? So basically, I'm going from the biggest thing that we know, which is a gallon. So 1 gallon here. And we know that it's equal to 4 quarts. In the case of this question here, we can stop here, right? Because it's asking us how many quarts in a gallon? Well, 1 gallon here equals 4 quarts. And this here is our correct answer. We didn't really have to do any conversions, because it didn't ask for cups or for pints and whatnot. So in this case here, we would just finish our question here. So 1 gallon here equals 4 quarts. They have the exact same answer. So the solution here is correct. They did the exact same thing here. They're asking the exact same thing. So obviously, how many quarts in a gallon? 4 quarts in a gallon. So I'm going to, again, we're working in the imperial system in terms of volume here. It's the exact same questions. So again, 1 gallon here equals 4 quarts as shown by our conversion here. So solution here is correct. All right, and then let's look at this here would be number 8 because number 7 was just a repeat of the question. Number 8 is asking, what is 12 divided by 1/3? So it's asking, what is 12 divided by 1/3 here? So again, we have 12 here. We're going to divide it by, this is the division sign here, by 1/3, and it's equals what number here. So again, when we're dividing fractions here, we have to make sure that we have to keep a rule in mind, right? So every time we are dividing a fraction or dividing by a fraction here, so here's the division sign, obviously. We can basically convert it to a multiply, right? We're basically converting division into a multiplication sign. And in order for us to do that, we have to flip our fraction. So when I say flip the fraction, I'm saying we're going to take the reciprocal of this fraction here. So every time we're dividing a fraction here, we can basically flip it to multiplication as long as we flip the fraction here. So when we talk about flipping the fraction, we are changing the numerator and the denominator. We are flipping the two signs here. So not flipping signs, we are changing places here. So 1/3 becomes 3/1, right? 3/1 here. So this here is going to be the reciprocal of 1/3 here. So again, we're multiplying by the reciprocal, right? So I can basically say that division is also the same as multiplication by reciprocal. By reciprocal here. So if we have this, if we have 1/3 is 3/1, then we simply have 12 times, and we're in multiplication because we changed it, right? We changed it to multiplication. 12 times 3/1 here. And we know that 3/1 is simply just 3, right? So we have 12 times 3, which is simply just 36. So 36 here is our correct answer for this problem. And as you can see, this here is also 36 here. So the solution here is correct. That's great. And then let's look at number 9. Number 9 is asking us 64 is 4 times the difference between Sarah's age, A, and 44. Assume, I'm guessing that's the word, assume Sarah is older than 44. Write an equation to determine Sarah's age and then find Sarah's age. Okay, so this here would be, this number 9 here. So it says 64 is 4 times the difference between Sarah's age, I'm assuming this is A, and 44. What did I do? 44, and then assume Sarah is older than 44. So it says here, write an equation to determine Sarah's age and then find Sarah's age. Okay, so in order for us to find Sarah's age here, we are going to have to create an algebraic expression for Sarah's age, right? So we can say here, let x equals Sarah's age here. So we know that let, because that's our unknown here. And it says here 64 is 4 times the difference between Sarah's age, which is now X, and 44, right? So we're talking about the difference between Sarah's age and 44 here. It's we're going to use subtraction, right? So we have here, this is X minus 44 here is the difference between Sarah's age and 44, X minus 44, obviously. And it says here 4 times the difference, right? So it says 4 times the difference here. So I'm going to have to write a 4 here, and this would equal 64, right? So this here equals 64. So this here is our algebraic expression for Sarah's age here, right? So it says 4 times the difference here. So the difference here is X minus 44, which is the age in 44. 4 times the difference is here. I'm multiplying this entire X minus 44 by 4 here, and this would equal 64, obviously. So now what we can do is we solve for X, right? We've written an algebraic expression here, and let's just simply solve for X here, right? So we have 4 times X minus 44 equals 64. We can get rid of the 4 by dividing 4 by both sides, right? So if we divide by 4 on the left side, we're simply left with here X minus 44. This would equal 64 over 4, right? And X minus 44 here would equal 64 divided by 4 would equal, I believe it's 18. Let me just double check that on my calculator. 64. Or it's 16, sorry. Yes, it's 16, my bad. 16 here. And then what we can do is we can move 44 over to the right-hand side by adding both sides by 44, right? So if we add both sides by 44, this left side simply becomes X. And we'll have 16 plus 44 here. So X here would equal 16 plus 44 equals 60. So, which means I know that Sarah's age here is 60. So now I've solved the problem here. So my algebraic expression, so this here was part A. This here was my algebraic expression. Or this here is an equation, actually. It's 2 algebraic expressions here. So this here is equation, and B is this would equal Sarah's age here. So Sarah is 60 years old. And as you can see, so the age of Sarah here is 60. That's good. So they basically did the exact same thing as I did. And they used algebra to figure out that Sarah's here is equal 60. So therefore, age of Sarah here is not 30 here. I think this is a misprint. It's 60 years old here. So I'm going to say solution is incorrect because they actually wrote the final answer as 60 and not 30 and not 60. So the solution is perfect, except the last statement. The age of Sarah is 60 years old. Is 60 years. So we're going to say it's incorrect just because the last part here they didn't write it 60 years old, just to help improve the system here. So that's number 9 here. Let's look at number 10, and then we have 2 more questions for the day here. So number 10 here is, again, how do you write 0.4 as a fraction? So again, these are very, very similar to the first 2 questions we did for today. So 0.4 as a fraction. So again, in this case here, we don't have a whole number part, right? We have 0.4 here, and we have 0 as the things that exist on the left side of the decimal place is 0 here, right? So we don't actually have anything on that side here, but we only have the decimal part. So we don't even have to convert it to a mixed fraction in this case here, because I didn't have a whole part. We can just simply convert it into a improper or a proper fraction here. So in this case, again, always my tens digit here. So tens digit, which means this here is simply just, if I want to write a decimal into a fraction here, it's decimal into a fraction, my denominator is always going to be 10, because it's only existing in the tens digit. And then I simply have 4, right, or whatever is written in the decimal here as the numerator. So I have 4 over 10 here is my fraction. And then what I can do, again, I can obviously reduce to lowest terms. So I have 4 and 10 here, both of them are divisible by 2, right? So I'm going to divide the numerator here by 2 and the denominator by 2. 4 divided by 2 is obviously 2. And then finally, 10 divided by 2 here is 5. So if I wanted to write 0.4 as a fraction in lowest terms, so I'm going to say here this is reduced to lowest terms, I can say that 2 over 5 here is my answer here. So this solution here is correct. 2 over 5 here is correct. As you can see, they converted 0.4 into 4 over 10, which is good, which equals 2 over 5. So this solution here is correct. Good analysis. Good analysis here. And then finally, the last question here, question 11, I have how do you simplify the square root of 200? So let's see. Question 11. How do you simplify the square root of 200? So again, when we're looking at the square root of 200 here, we have a square root of 200 here, right? So again, we have the square root of 200 here. This 200 goes inside the square root. So in order for us to simplify the square root here, I'm assuming that we're looking at the simplified radical form of this guy here. You could take the method as solution, like I believe the solution is looking at here. So we'll go over that as well. But if I want to simplify the square root of 200, again, I'm going to do the simplified radical form of that first. So let me do that for you. My pen's kind of going wonk. There we go. Simplified radical form is what I'm assuming what the simplified term means. So let me just do that first. Again, I'm finding the prime factors of 200, right? So I know 200 here is an even number, so I'm going to take root 2 out here. And dividing 200 by 2 here gives me 100, right? 100. And I actually know that the root of 100 here equals 10, right? So if I know the root of 100 here equals 10, then I simply just have root 2 times 10 here. Or I can say here, it's simply 10 root 2. And this here is going to be the simplified form of the square root of 200. If I were to find out the decimal places for this problem here, I can, again, do the method as solution, right? So again, I have 200 here. I can do the long division guy here, right? So again, what I'm going to do is I'm going to take the first digit here. I have 2 here. So what I'm going to do is 1 squared equals to 1, 2 squared equals to 4, right? So I'm going to put 1 here. I have 1, which is great. 1 squared is 1, which means I subtract 2 from 1 here is equals to 1. I'm going to bring down the 200 here. And then I say I doubled the quotient here, which is now 2, right? So that's 2. And then I'm thinking of a number that would go from 2 times what number squared here would give me 100 here. If I put 5 here, I would get 25 times 5, which would give me 125. So this here would be incorrect. So we'd have to go 24. So not 25, but 24. So put 4 here. 4 is here. So 24 times 4 here would give me 96, right? This here would subtract it well. So 100 minus 96 here equals 4. And then what I can do is, so again, they did the exact same thing here. I have 24 again here. And what I'm going to do is I'm going to add 24 and 4 together to get to 28 here. So 28 will be my next kind of divisor here. It's going to divide into 400, right? And again, 281, because I can't put a 2 here and 2 here, right? Just because if I did that, I would go over 400 here. So in this case, I've put simply just a 1 here, right? So I have 14.1, and then it's going to subtract by 281. So I would get 129 here. And this here would be my final answer, right? 14.1 is the square root of 200. In this case, they did 4 decimal places, which is perfectly fine. I guess I will do also 4 decimal places. Again, 281 plus 1 here is 282. and then thinking of a number that goes into basically 12,000. I believe, it should be 11,000 here. I think I subtracted poorly. 11,900. And this here would be the number, let's see. In this case, I would say, I want to say it's 4, right? 282 times 4 would give me 11296. So I would have a 4 here, and a 4 here, which would be 11296. Subtract both of these numbers, I would get 604 here. And this here is my final answer, right? The top part here, using method as solution, I've basically solved for the approximation of the square root of 200, and this here would equal 14.14. And this here, again, is an answer for this question. But again, if I were to simplify the square root of 200, it's simply just root 2 here. So this here, we could have done this long solution to figure this out. Or if you actually know root 2 here actually equals about approximately 1.41. So if I multiply that by 10 here, I would get 14.1 here. So this it's very, very similar to our answer here. So that is also another way of solving this this solution here. So I'm going to say here solution is correct. Solution is correct. Or I'll say the simplified radical form for the square root of 200 is 10 root 2 root of 2, but the long division method to approximate the square root of 200 is correct. So we're going to say for the solution here is correct, and we are done for this video. So again, we did here 11 questions. It ranged from basically grade 8 to grade 9 math. What we're going to do is I'm going to take a break for an hour, and then I'm going to come back here about noon Eastern. And what we're going to do is we are going to look at basically any questions from basically grade 10 all the way up to grade 12 calculus. So stay tuned for that. Again, my name is Joey. I stream here at OneClass from basically Monday to Friday. I stream math on Monday, Wednesday, and also on Friday. So you can tune in between those days, to look at to tune into math. I stream at 10 Eastern, also at noon Eastern for all 3 days of the week. And then I also teach chemistry on Tuesdays and Thursdays, and I stream from noon Eastern and at 2 p.m. Eastern as well. And so I stream chemistry during those times. So again, thank you so much for watching. I will come back in about an hour, and I will have a brand new set of questions for you, and we can solve those together as well. Most important thing, again, here is to keep learning, obviously, but also to, again, stay safe, stay healthy, and yeah, thank you so much for watching. Take care.